Discover Geography, Lesson 4-1, Population. The current population in the United States is about 318 million. Go ahead and pause this video if you need to and make your best guess as to what the population in the United States will be 100 years from now in 2114. And think about why you chose that particular number. What things do you think would either add to or subtract from the U.S. population over the next 100 years? All of the factors that you imagine might affect the U.S. population, whatever conclusion you came to, whether you thought that we would have a much larger population, much smaller population, about the same size population, all of the factors that might influence the size of that population have to be able to fit somewhere into this population equation. This is an equation representing how populations change over time. So the population at time 2, so this would be 2114 in the example we just thought about, would be equal to the population at time 1, our starting population in 2014, plus everyone who was born in that time frame, minus anyone who died, plus the immigrants, people who moved into the country from somewhere outside, minus the emigrants, people who moved from the United States out to some other country. So any factor that would influence the size of the population is going to do it either by changing how many people are born, changing how many people died, or changing the level of movement into or out of the country from outside. For the rest of this lesson and the next one, we're going to focus in particular on the births and deaths. Then in the lesson after that, we'll look at immigration and emigration as forces that shape population. So to understand changes in population, there are a few terms that we need to know, a few concepts that we use to describe how populations change. The first is the population growth rate. Population growth rate is the percent growth per year in the total population of whatever unit we're interested in. So here we've got the population growth rates by country around the world on the map there. So whatever percent of the existing population you're going to add in the next year is your annual population growth rate. And an important figure to keep in mind, if you have 1% growth in your population, that will lead to a doubling of your population in about 72 years. Because if you have 1% growth this year, the next year you have another 1% growth. That's 1% not just of the original population, but also of the added population that you grew between the first and second year. So if you start with a population of 100, 1% growth, that's one more person, so that's 101. Then the next year you add 1% of 101 rather than just 1% of 100. So that growth rate compounds. So you can double your population in 72 years if you have a 1% annual growth rate. Life expectancy at birth refers to the estimated average number of years that a child born right now will live. So the life expectancy is looking into the future for children being born right now. And so you can see on this map a great range of life expectancies that exist in different countries of the world. Here in the United States, we're in the upper 70s. There are a few countries like Sweden and Australia that are upwards of 80 years as the life expectancy at birth for children being born right now. And then you can see in sub-Saharan Africa and in Afghanistan, life expectancy is less than 50. However, this life expectancy, because it's an average number, can be skewed if you have a really high child mortality rate. And that's what's really going on in sub-Saharan Africa. It's not that most people who live there are going to die before they hit age 50. What's going on there is that a lot of the children being born right now are not going to make it through their first year. And a lot of the ones that make it through their first year are not going to make it to 5 years old. Once you pass about 5 years old, you are kind of in the clear from a lot of these factors that cause these high infant mortality rates. And so you're likely to live a somewhat longer life. But once we average everyone together, both the people who are going to die in their first year of life and the people who are going to make it past that, the average life expectancy ends up quite a bit lower. The fertility rate refers to the average number of children that a woman will give birth to within a country. So here on this map, you can see the fertility rates of different countries of the world. You see very high fertility rates in sub-Saharan Africa, lower in most other parts of the world. And a key number to remember when we think about fertility rates is 2.1. This is what's referred to as replacement fertility. This is the fertility rate that's necessary in order to keep the population stable in the long term. So on average, each woman within a society would need to have 2.1 children in order to keep that population stable with no emigration or immigration going on. So the 2 is easy to understand. We have about a 50-50 ratio of men and women in society, and so each woman needs to have a child to replace herself and a child to replace one of the men. The 0.1 is on there because there are actually a slightly larger number of boys born than girls. And so you have to have slightly more children than just the 2 to ensure that the whole population is going to be replaced. The sex ratio at birth refers to that ratio between boys and girls being born. So in a natural situation with no extraneous interference with the sex ratio at birth, sex ratio at birth is going to be a little over 1. So it's the measure of the number of boys born per girl who is born. And there are naturally slightly more boys born than girls. However, you see some countries with an extremely skewed sex ratio at birth, countries like China and India, where you have far more boys being born than girls. This is a result of deliberate interference with the sex ratio at birth. In countries like this, we see high rates of sex-selective abortion, and we see high rates of choice of having children being driven by the gender of the children you already have. So families that have a daughter will make a point of going on and having more children until they can get a son, whereas families that have a son won't necessarily make the effort to go on and have a daughter. For these reasons, you end up with a very skewed sex ratio at birth because families in certain areas of the world value sons much more highly than daughters. Sons can carry on the family name and the family business, and sons bring in wealth to the family when they get married, whereas in these societies, daughters take away wealth. When a daughter gets married, the family has to provide her with a large dowry, which is basically a giant monetary gift to her husband and her husband's family. So in countries where these are common customs, there's a big incentive for families to try to have sons rather than daughters. And so we can see these social processes being reflected in the sex ratio of children being born. When we want to understand the structure of a population, we can see a lot of what's going on by looking at a type of graph called a population pyramid. Population pyramid is basically 2 bar graphs sitting back to back, one for males and one for females. The length of each bar represents the number of people of that gender in a particular age bracket. The population pyramids we're going to look at have 5-year age brackets. So if you look at the lowest bar on the right-hand side there, that indicates that there are something like 10.5 million 0 to 4-year-old girls in the United States in 2012 when this graph was created. You look at the bottom bar on the left-hand side, you can see that there were about 11 million 0 to 4-year-old boys being born in the United States. In the United States, we tend not to interfere with the natural sex ratio at birth too much, so we see slightly more boys being born than girls. And if we look up the rest of the population pyramid, we can see for each age bracket how many males and how many females there are. And if you look at the very top of the pyramid's going to taper off at the top because everybody eventually is going to die when you get old enough. You can see that the bars on the female side are actually a little bit longer in those oldest ages. If you look at the 80s and 90s, you can see those bars are clearly longer. Women, on average, tend to have a longer life expectancy than men, especially in places that have a modern medical system that reduces deaths in childbirth for women. So we see slightly more boys being born, but slightly more women living into very old ages. And here in the United States, we see that from about the 50s on down, the sides of the population pyramid are fairly straight up and down. That is, each age bracket is roughly as big as the one before it. That we're having basically as many children in each generation as we had people in that generation before. This is an indicator of a fairly stable population in terms of births and deaths. The United States population is growing largely because of immigration, not because of what we call natural increase of people having more children than there were people in the previous generation. Here's a population pyramid for China. And what we see here is that it tapers off to the top in the same way that the US pyramid does. Near the bottom, however, it narrows in a bit. The most recent age brackets in China are substantially smaller than the age brackets for people in their middle ages. This is a result of China's one-child policy. China has put strict limits on the number of children that people can have. And so people that fall under the most restrictive rules within this policy can only have one child per couple. So this creates a fertility rate well under replacement fertility for those people. And so we're seeing smaller and smaller generations since that policy has been implemented. And finally, here's an interesting case, the country of Qatar. This is a small oil-rich country in the Persian Gulf. And what we see here is if we look at just the very last few age brackets, we see the population pyramid widening out towards the bottom, which indicates that we're having more and more children over time. So there's a significant natural increase to Qatar's population. We also see a big bulge around the middle ages, and that bulge is much bigger on the male side. Here we see an impact of immigration on a country. Because Qatar is an oil-rich country, there's a lot of demand for people to come in to work on the oil rigs and in related industries where there's a need for a large amount of low-skilled, low-paid labor. So there are a lot of people migrating to Qatar during their working years, doing this kind of work, and then leaving when they are able to retire. And so we see this extra bulge in the middle areas of the population of Qatar. And that bulge is much larger for the men because most of the jobs that are attracting these migrants are traditionally male-dominated jobs, like being an oil rig worker. So we can see a lot about the structure of a place's population, what's going on with it, by looking at a population pyramid.